Okay, so to sum up whatever you guys have learnt in this chapter, so first thing was RMS. So root means square value. Now RMS value was what? The heat liberated by a resistance when an alternating current is passing in a given amount of time, where the same heat is liberated when a steady current is passed through the same resistance for the same amount of time, correct? So we have IRMS is equal to I naught by root 2 or ERMS is equal to E naught by root 2, right? The next thing what you guys learned was a phase diagram or a phasors. So phasors was giving a relation between the EMF and the current, correct? Then you learned about an AC through a pure resistor, pure inductor, pure capacitor, right? And then combination of R and C, right? So in a resistor they were in phase, inductor EMF was leading the current by pi by 2. In a capacitor, EMF was lagging the current by pi by 2, right? Then you learnt about inductive reactance XL, which is omega L or 2 pi FL. Then capacitive reactance XC, which is 1 over omega C or 1 by 2 pi FC, right? Then in LCR circuit, you learnt about impedance, which is root of R square plus XL minus XC the whole square, right? And then tan phi was given by XL minus XC divided by R, right? So this is what you learnt in LCR. Then we moved on to resonance. See, in resonance, what did we learn? A resonance is a condition where XL and XC are equal to each other. In other words, the whole LCR circuit acts like a pure resistive circuit, right? So the current will be maximum and the impedance will be minimum. Now, the resonating frequency was given by omega naught is equal to 1 by root LC or F naught is equal to 1 over 2 pi root LC, correct? So this is what we learned in resonance. Then we moved on to the sharpness of the resonating curve, correct? So the sharpness was given by omega naught L divided by R, right? Now this was nothing but the Q factor or the quality factor. Now Q factor is also given by one more formula, which is 1 by R root L by C. Okay, since we are talking at resonating frequency, so we have omega naught is equal to 1 by root LC, correct? So we substitute that and we get this formula 1 over R root of L divided by C. Okay, then we moved on to power, right? So power, we derived the equation for power and the formula what we got was ERMS IRMS cos phi, right? Cos phi was called as the power factor, correct? So after power, we then moved on to a very important topic, which is transformers. So transformers, we looked at how a transformer worked. Because of mutual induction it works, and the core has to be laminated core because to get rid of the eddy currents. And then we also saw how the EMF and the basically EMF meaning the voltage and the current will be induced in the secondary due to the primary, correct? So we deduced the relation ESIS is equal to EPIP, correct? So this is what we learned in transformers. And then we learned about uses and then some losses in transformer, right? So this is the whole alternating current chapter. Now in the next video onwards, you will be seeing only problems based on whatever you guys have learned. So before we do the problems, so I would say that you go through the formula once and then you start the sums.